Imagine the vast silence of space, where stars whisper secrets across eons, and humanity stands on the precipice of a dream that defies the void. Picture a colossal vessel forged from gleaming metal, not unlike the ancient alchemists' pursuit of turning base elements into gold, hurtling toward a rusty red world that has haunted our imaginations since we first gazed upward. This is no mere fantasy. It's the audacious blueprint of a mind that sees beyond the horizon, Elon Musk's vision for Starship, a behemoth designed to shatter the barriers between Earth and Mars. What if the journey to another planet, once a perilous odyssey spanning years, could be compressed into mere months, fueled by engines roaring like thunder and a network of satellites weaving an invisible web of connection? In this cosmic ballet, stainless steel endures the inferno of re-entry, cryogenic fuels slumber in chilled repose, and 33 rapturous hearts propel us forward. Yet, amid this symphony of innovation, a profound mystery lingers. How does one man's relentless drive echo the universe's own unyielding expansion, pulling us toward destinies we can scarcely comprehend? We find ourselves drawn into this enigma, pondering the fragile thread that connects our earthly ambitions to the infinite expanse. As we delve deeper, the question arises, woven into the fabric of our shared wonder, could this vessel not only bridge worlds, but redefine what it means to be human in the cosmos? Venturing further into this grand tapestry, we must first grasp the immense canvas upon which this vision unfolds. The solar system itself, a sprawling arena where planets dance in elliptical grace around a fiery sun. Mars, that enigmatic wanderer, hangs like a blood-orange jewel against the velvet black, its surface etched with canyons deeper than any on Earth and volcanoes that dwarf our mightiest peaks. Olympus Mons, the largest in the known universe, rises 21 kilometers high, a silent sentinel guarding secrets of ancient rivers and frozen polar caps that hint at a watery past. Yet, the journey to this distant sibling has always been a gauntlet of cosmic perils. Radiation storms that pierce flesh like invisible arrows, the relentless pull of gravity wells, and the yawning gulf of time that stretches voyages into soul-crushing isolations. Enter Starship, Elon Musk's magnum opus, a reusable spacecraft standing taller than the Statue of Liberty, its stainless steel hull shimmering with the promise of durability born from earthly forges. This material, chosen for its strength at cryogenic temperatures and its ability to withstand the blistering heat of atmospheric friction, represents a paradigm shift from fragile composites to robust resilience. Imagine the scale: a vehicle capable of lofting over 100 tons to orbit, refueled in space like a nomadic caravan drawing from orbital oases. Musk envisions fleets of these giants, not as one-off explorers, but as the workhorses of interplanetary migration, turning the red planet into a second home for humanity. The contrast is stark against the fragile blue marble of Earth, with its swirling oceans and teeming life. Mars appears barren, its thin atmosphere a whisper compared to our robust blanket of air. But beneath that desolation lies potential. Vast reserves of water ice, carbon dioxide that could be harnessed for fuel, and a day-night cycle eerily similar to our own. Starship's design amplifies this potential, integrating 33 Raptor engines, each a marvel of methane-fueled power, generating thrust equivalent to lifting a small city skyward. These engines, burning liquid methane and oxygen, promise efficiency that slashes travel times, compressing what was once a 9-month trek into a swift 6 months through optimized trajectories and in-orbit refueling. The emotional weight of this expanse presses upon us. It's a reverence for the void's indifference, yet a defiant spark of human ingenuity that lights the way. As we stand on the threshold, the landscape expands in our minds. Earth's bustling continents giving way to the sterile beauty of Martian dunes, where dust devils whirl like forgotten spirits, and the faint gravity invites leaps that mock our terrestrial bounds. This is the stage set for transformation, where technology meets the mythic, and the cosmos beckons us to step beyond our cradle. Beneath the visible grandeur, hidden signals pulse like coded messages from the stars, revealing the intricate dance of engineering that makes Starship's promise real. These are not sights for the naked eye, but data streams captured by sensors and simulations, anomalies in thrust curves and thermal readings that engineers decode like ancient scribes unraveling hieroglyphs. Consider the telemetry from Raptor engine tests, where pressure waves and exhaust plumes are analyzed through high-speed cameras and spectrometers, uncovering efficiencies that propel us closer to Mars. The stainless steel structure, subjected to cryogenic stresses, emits subtle vibrations detected by accelerometers, ensuring it can endure the bone-chilling cold of liquid fuels without fracturing. These unseen emissions, radio frequencies from Starlink satellites integrating with the ship, providing real-time bandwidth across the void, form an invisible lifeline, countering the isolation of deep space. In ground tests at Boca Chica, Texas, prototypes have roared to life, their flames painting the sky, while instruments measure the precise stoichiometry of fuel mixtures, optimizing for the long haul. The intrigue builds as we ponder these anomalies. A slight fluctuation in engine gimbal could mean the difference between a smooth Hohmann transfer orbit and a catastrophic deviation. Through finite element analysis, engineers simulate the hull's response to re-entry plasmas, where temperatures soar to 1,600 degrees Celsius, and the steel's superalloy composition glows with resilience. These hidden signals whisper of a future where Mars is not a distant dream, but a tangible destination. Their detection a testament to human persistence in piercing the veil of the unknown. The wonder intensifies as we realize these are echoes of the universe's own hidden forces, gravitational waves and cosmic rays, that Starship must navigate, turning peril into pathway. In this moment of revelation, we pause to feel the warmth of connection, as if the stars themselves lean in to share their light with our weary souls. The ingenuity of Starship stirs something deep within us, a shared heartbeat of aspiration that binds dreamers across generations, reminding us that in the face of infinity, our emotions are the true fuel for exploration. Tracing back to the origins, we journey to the primordial forge where such visions are born, echoing the universe's own genesis from chaos to order. In the Big Bang's fiery crucible, elements like iron and nickel coalesced into the very metals that now form Starship's hull, stainless steel drawn from Earth's ancient ores, refined through millennia of geological alchemy. Musk's dream germinates in the dusty plains of South Africa, his birthplace, where a young mind devoured science fiction, birthing ideas that would collapse distances as surely as a black hole warps space-time. The Starship concept emerges from earlier iterations, Falcon rockets testing reusable landings, their fiery descents like phoenixes rising from ashes, evolving into this ninth iteration, a symphony of iterative design. Consider the Raptor engines. Born from the need for full-flow staged combustion, they trace roots to the chemical reactions that powered the first life on Earth, methane bubbling from volcanic vents in a reducing atmosphere. Over eons, these elements formed, compressed in stellar nurseries, then scattered by supernovae to seed our planet. Starship's cryogenic fuel storage, maintaining liquid methane at -162 degrees Celsius, mirrors the icy comets that delivered volatiles to early Mars, preserving them against the vacuum's boil. This technology, with insulated tanks and zero boil-off systems using subcoolers, ensures propellants remain viable for months, enabling the 6-month sprint via gravitational slingshots around planets. Philosophically, it's a reflection on emergence. Just as simple atoms birthed complex stars, Musk's vision assembles disparate technologies. Starlink's constellation of over 6,000 satellites providing laser-linked broadband, cutting latency to Mars from minutes to seamless streams. We delve into a sub-narrative of the Raptor's development, initial prototypes exploding in spectacular failures at McGregor test sites, each detonation a lesson in valve timing and turbopump synchronization, leading to engines that produce 230 tons of thrust each, 33 combining to rival the Saturn V's might. This slow formation evokes the mythic, dust gathering into worlds, time as the patient sculptor, yet grounded in science. The Hohmann transfer orbit, minimized by in-space refueling, shaves months off travel, reducing radiation exposure from 600 millisieverts to half. Emotionally, it's nostalgic, a hearkening to humanity's nomadic past, wandering from African savannas to lunar footsteps, now poised for Martian soil. The cryogenic tech, with its helium-pressurized systems, prevents vaporization, much like how ancient ices preserved life's precursors. In this elemental reverie, we see order emerging from the void, Starship as the vessel carrying our species' legacy forward, a bridge across the cosmic chasm. These secrets are etched in the records of time, much like light from distant galaxies captured by telescopes, allowing us to read the universe's autobiography. In Starship's case, the archives are digital simulations and test data logs, fossils of innovation preserved in servers at SpaceX headquarters. Analyzing thrust profiles from suborbital hops reveals how the stainless steel belly withstands aerodynamic loads. Its 301 alloy composition, a relic of metallurgical evolution. We decode these memories through computational fluid dynamics, tracing how fuel sloshes in tanks during zero-gravity maneuvers, ensuring stability for the long voyage. This act of reading the past mirrors paleontologists unearthing dinosaur bones, each data point a clue to refining the design that could sustain human outposts on Mars. The voices of evidence resound through the scientific chorus, from NASA's collaborations to SpaceX's milestones. The Artemis program eyes Starship for lunar landings, with the Human Landing System variant drawing on Raptor tech. Researchers like those at the Jet Propulsion Laboratory model trajectories, confirming that with 33 engines and refueling, transit times drop to 6 months. Key discoveries include the 23 integrated flight test, where Starship reached 150 kilometers, telemetry validating Starlink's role in uninterrupted command links. Elon Musk himself, in peer-reviewed forums and TED Talks, outlines the vision, backed by simulations showing cryogenic storage enabling multi-ship fleets. Delving into invisible landscapes, we uncover the subsurface realms that shape Starship's prowess, the quantum dances within engine nozzles, the dark energy analogs and fuel efficiencies. Beneath the hull lies a lattice of thermal protection, unseen layers shielding against the void's chill and re-entry's fury. Starlink's mesh network forms an ethereal web, its phased array antennas beaming data through the plasma blackout, a hidden structure defying isolation. These depths evoke awe, contrasting the ship's macroscopic scale with microscopic precision, like neurons firing in a cosmic brain. Yet, against all odds, life persists in the harshest voids, much as microbes thrive in Antarctic dry valleys, paralleling potential Martian biospheres sustained by Starship's deliveries. Human resilience mirrors this. Crews enduring isolation in analog habitats like HICs, where psychological fortitude blooms amid desolation. Poetically, it's a testament to endurance. Fragile forms defying entropy, just as Starship's tech nurtures fragile hopes for colonization. Expanding horizons, we gaze upon refuge worlds like Europa's subsurface ocean, where cryovolcanism hints at habitability, or Titan's methane lakes, environments Starship could probe with extended missions. Enceladus spews water plumes, shocking with organic molecules detected by Cassini, facts weaving wonder into our narrative of potential life harbors. This awareness sharpens through tension, urging us to confront the fragility of our pursuits, a cosmic alertness that binds us in urgent reflection. Human scars mirror these cosmic tales, our environmental collapses echoing Mars' lost atmosphere. Stripped by solar winds, much as deforestation ravages Earth. Societal hubris, from ancient civilizations felled by overreach to modern climate crises, parallels the risks of unchecked space ambition, fostering empathy for balanced progress. The collapse unfolds viscerally, systems unraveling as overtaxed engines falter, or fuel leaks in simulation, mirroring societal breakdowns in resource scarcity. In poetic realism, we envision Martian outposts failing without sustainable tech, a grave crescendo of intensity. Hidden stakes lurk in political undercurrents, economic rivalries between nations like the US and China vying for space dominance, moral dilemmas in resource allocation, historical patterns of exploration's dark sides, colonial exploitation, analogized to potential Martian inequities, contemplated with controlled intensity. Futures balance on choices, a dystopian path of exploitation leading to barren colonies, or hopeful stewardship fostering thriving habitats. Personal responsibility lifts us toward the climax, reflecting on ethical legacies. In reflective closure, the narrative resonates symbolically, stirring introspection on our place in the stars. Echoing the opening, we ponder, if Starship bridges worlds, what mysteries of self will we uncover in the red dust? This legacy in light connects to humanity's arc, survival ethics spanning generations, metaphors of civilizations as fleeting stardust, lessons echoing through time.